is Pratha and the Renaissance Trust. We have been into skilling, volunteering activities, and podcasts since last 5 years. And we are a group of students and professionals who have been officially felicitated by Government of India. We are into Asia Book of Records and India Book of Record for hosting the highest number of global dignitaries. And previously, also we have hosted a lot many people from international organizations, and this is the second session with NASA. Thank you so much, ma'am, for giving us your precious time. We understand that every hour is important, specifically when it comes to such an important organization as NASA.
Yeah, of course, it's my pleasure to be here. Thank you for having me.
Thank you so much, ma'am. Let's start with the questions. But the point is, meanwhile, as we are discussing about the projects, programs, and AI integrations and supercomputers, in case any of our live audiences want to ask questions in the comment section, it is open. They can ask questions, and I will be taking it up and putting forth to our honorable guest. First question that I would like to put forth is again about as AI is getting applied in different industries in the data analytics. When it comes to Gen AI, it is getting rather replacing people so in every nation corner. So how it is going to affect NASA? So AI plays a very critical role in space exploration. It has been having a critical role since decades. Now the point is the way AI has changed. Now we have GAN and now we have GPT. So how does NASA ensure that the reliability of AI systems used in the autonomous spacecraft operations, specifically in the high stakes environment like Mars or Europa, or moons like Europa, or not even Mars or Europa? Let's talk about the satellites that we have uh, around the Earth. So how the autonomous missions that are using AI, how NASA is ensuring the reliability of it? Is there like, because hallucinations are innate part of AI that we all faces, so NASA must be facing hallucinations from the AI also. So is that effect largely?
So, all of the software that we use, and I call AI, the AI algorithms, they kind of fall in the software category, that we use. We have a and for our hardware too, anything we put in space or anything that we create, we have very specific verification and validation requirements, at the smallest level to the system level. So any AI algorithms or anything that we put in space or any kind of software, they have to go through these verifications and validations. And these are requirements that we have, and they take into account, the things about the technical accuracy, the ethical use, all of those things, and so what we do is that once we have it, when each of our algorithms are tested to make sure that it meets our requirements. And then, so the way the requirements documents go is this, we've got some general guidelines, not very general, pretty specific. And then each mission, they will actually create specific requirements for their algorithms. And they're vetted. Those requirements are reviewed by independent teams to make sure that that the team that's working on it is not blindsided by something else. So after all of this, then we put up then we will actually install it in a spacecraft or patch it on a spacecraft. So that's kind of how we have a pretty robust system of ensuring reliability of our hardware and our software. So we
And
do
that's
rely on that.
right, and that's an exhaustive steps that you follow, and it has to be followed because even a micro or a minuscule deviation can affect the spacecraft to a significant scale. Now,
Yes.
in alignment, yeah, exactly. So it can lead to failures, not just about monetary failures that you are speaking about. It can cost lives also. Now coming to a similar question in that line. So when AI helps astronaut make decisions, like including Gen AI and chatbots. So our astronauts, when they are like using AI assistance for making decisions, how does NASA make sure that computer choices are safe and fair? For an example, if the AI has to choose between finishing a mission or protecting astronauts, who decides what's most important? So
So
supposedly it is an autonomous or semi-autonomous missions. Yeah,
yeah, so NASA has, like most organizations, we have values that we have, that the organization follows, and each of us embrace it. So NASA's values, I'll tell you, is safety, integrity, teamwork, inclusion, and excellence. Those are the values that we follow every day and in everything we do. So if you notice, safety is the one I listed first. So that is our highest priority. So by safety, it prioritizes, and even in safety, there's a priority system. Because we have to be very specific. In safety, it prioritizes the safety of its personnel, like the astronauts in your question, the public, and then the assets that have been entrusted to the agency. And without the safety is a cornerstone of mission success. So there's really no question on whether you cannot finish the mission if you don't have the astronauts. I mean, that's automatically a mission failure
yeah.
if you lose the astronauts. So that decision is really not made that way. I mean, first we will try to save the astronauts. The astronauts come first, and more than anything else. They come first. And then second, would be the public. And then third is our assets, like our facilities, our spacecraft, all of those things. So yes, so that's a
So
very brief
how,
answer.
yeah,
You
so
cannot.
how is this particularly ensured? This is the same kind of
It's ensured by by the same verification and validation methods that we use. Um,
exactly.
and and of course, when you write AI, you can write rules, right? I mean, so these, our values
Absolutely.
are in, our rules are actually incorporated. Our values are incorporated in those rules.
Right. Ma'am, in alignment with this, uh, like across the world, whoever is passionate about NASA are excited about the Artemis program, in which NASA's is aiming to return humans to the moon. And Artemis program has Artemis 1, Artemis 2, Artemis 3. So eventually, um, in the Artemis 3, they are, or NASA is opting to have humans on moon. So how are intelligence systems shaping mission planning in this case, crew safety that we have previously discussed, and operational efficiency, specifically when it's coming to as important missions as like Artemis missions, and how
Right.
things have changed from the Apollo era?
Yeah. So first, let me talk a little bit about the difference then between Apollo and Artemis.
A lot
There's
of,
some.
it has been decades, so there has to be a lot of differences. Yeah.
Right. So there's a differences in the program goals, right? In Apollo, we were trying to show that we could send a person to the moon and bring them back safely. The Apollo mission, it landed on the Earth-facing side of the moon. And what I mean by that is that the moon is tidally locked with the Earth. So the one side of the moon sees Earth, the other side of the moon does not see Earth. It never sees Earth because because these two planetary bodies are tidally locked. So with NASA's Artemis program, we're exploring the moon for scientific discovery, to advance technology, and to learn to live and work in another world. And we're doing this in preparation for human missions to Mars. So if you think about it, the moon is closer than Mars. So first we learn to work on the moon before we go to Mars. And if you think the way the early explorations were held in the early days, people did not circumnavigate the globe immediately. First, they went to you know like their neighboring countries. Then they went a little bit more into the oceans, and then they went to India, and then the circumnavigation around the globe came later, right? So you do it step by step. So this is our step by step approach, and Mars is far. When we send humans there, it's a 5-year mission. The moon is not that far. We can bring them back within a day or so. But so it's not that far. So it's so that there are a number of things we want to achieve with sending humans with going back to the moon. The other thing we're also doing is we're collaborating with commercial and international partners to establish the first long-term presence on the moon. And if you notice, NASA has something called the Artemis Accords. We work with the U.S. State Department to develop those Artemis Accords. And what that is, it establishes a framework for cooperations in the civil exploration and peaceful use of the moon, Mars, and other astronomical objects that we might go to. And it's grounded in the Outer Space Treaty, which was signed in 1967. Just for your information, India signed the Artemis Accords in June of 2023. It was the
Yes.
27th signatory to the Artemis Accords. And recently we had the 54th signatory, which is Bangladesh. I mean, they just signed in April, just a few weeks ago. So, so we are going, so all of the nations, they're signing up to the Artemis Accord so we can, so we can explore this peacefully and together. So there's some big differences, and in Artemis, we will not necessarily be going to the Earth-facing side of the moon. We'll be going to the dark side of the moon and to the polar regions as well, because there's a lot of interesting science that is there. So now to answer your question, how AI would be used in Artemis. Okay, so as I said before, safety is NASA's highest priority. So human safety is key to returning astronauts to the moon. So we have to focus on safely landing the spacecraft, conducting operations safely, and then bringing those astronauts home safely. It all has to be done safely because that's our highest priority. So for Artemis mission, we're going to be using AI for mission planning, to look at the lunar surface, crew health and monitoring, mission control, and other support. So I'll give you a couple examples. This is a really interesting topic. It's a big topic, So you think about lunar landing. Okay, where do you land? How do you know where to land? Okay, so where we go is a balance between where we can land safely, because if we're not, if there's a crater, if there's rocks, if there's, if the spacecraft is going to fall over, we don't want to land there. We want to land in a nice kind of a flat area, right? And then we have to balance where we can go with where we want to go for the interesting science and technology development, and the place that can give us experience working in another planet. So so things to consider in selecting the landing site. It's the kind of terrain that you have. Is it rocky? Is it a crevice? Is it plain? So we will be, so that's going to be important. If you can imagine, it's the spacecraft landing somewhere and then the astronauts walk out and they just fall down a canyon. I mean, it will take them forever to come back up, right? So we don't want that. So we want to be very careful about where we land. The
Right.
lighting conditions are very important on the moon. So in the moon, with the Viper project that we lead out of Ames Research Center where I work, it turns out, we've spent a lot of time identifying when you see a dark area, is it a shadow or is it a crevice? Is it a canyon? Right. And
Right.
it takes, and that's not clear. So the lighting conditions are very important, so you know where you're landing. Additionally, the lunar day is about 29 and a half Earth days. So this means the lunar night is about 15 days. So during the nighttime, our we're not going to be having any solar light. That means our solar panels are not charging, and we're not producing power. So everything has to be done on batteries, including staying warm. And it gets quite cold there. So there's another issue. And then, of course, we have to think about communication back on Earth, because there's no direct line of sight from the far side. So they have to wait and identify and know when a satellite is passing overhead to communicate, to send the communication. So we'll be using AI for, probably for relative terrain navigation that we used on Perseverance. On Perseverance, in the early Apollo missions, when they landed, they did it by visual line of sight. That's how the astronauts figured out where to land. Here for Mars 2020, for the Perseverance rover, we used relative terrain navigation, which used a number of cameras, a visual system, to identify what was the terrain, and identify a nice flat surface to land. And that all happened autonomously. So we'll likely use that, for landing, and so you can see there's a lot of things there. Let's see, what else? Crew health monitoring. So astronaut health monitoring is very essential, since we prioritize, crew safety and safety in general. So during space missions, there's isolations. We don't have hospitals on the moon. There's the medical
Yes.
supplies is what we take there. That's it. And then long duration, staying in low gravity for a long time, and a higher radiation environment, that's going to have an effect. So we're developing wearable devices, that will transmit data from the astronauts about astronauts' medical, their well-being. And using AI, we should be able to provide real-time insights into their physical and mental health. The other thing we're also trying to do that's very important, since we don't have that many, since medical resources are limited on the moon, there's none right now, right, is that we're trying to look at data to predict, is this a precursor to certain kinds of health conditions? If we're seeing this kind of biomarkers, does this mean this person is going to be getting sick later? Will they have the flu? Will they get cancer? Do they have too much radiation exposure? Things like that. We're also looking at that, and we'll be using AI to come to those conclusions. And then, of course, there's mission operations too. There's a lot of data that the spacecraft will have, and the mission parameters, and we'll be using AI to support risk management, by predicting hazards and recommending preventative actions. And it can analyze data, forecast risks like system failures, radiation exposures, crew fatigue. It can also look at the weather data that we collect from other satellites, and and forecast if anything's going to happen there. So that's, just think about, the moon doesn't have an atmosphere, but think about, when you watch the movie Martian, think about that windstorm that happened at the beginning, or that dust storm that happened at the
Right.
beginning of the movie, right? If you used AI and if you knew about it, then they could have taken
Yes.
the proper steps in a timely manner, right? So those are just some of the areas. This is a very rich area that that one can talk about for a long time.
Yeah, and the best part is it's not just we are tackling the issues of outer space. I mean, the very approach that we are taking, it is if it is about weather forecasting, or identifying, or about predictive maintenance of machines, or just predicting the health of the astronauts, it's not going to stay back for space technology alone, but it's also going to be possibly going to be used in some way or the other way in other industries, or for our own benefits in the earth itself. And the best part of it,
Absolutely.
exactly.
Yeah, absolutely. We all of the technologies we develop, I mean, they are used in everyday lives. Okay, I mean, the NASA spinoff, is something anybody on this call can look up. And it gives you, by every year we list how our technologies have been, how we've sent it off to the private sector and how they're benefiting, in daily lives, right? So I mean, you can imagine, we come up with ways to predict, you know, come up with predict if somebody's going to get ill. I mean, that's, you and I can use it here on Earth. You don't have to be at the moon to use it, right? You can use it anywhere.
Exactly.
Right. So I think so many of our tools are used that way. I mean, you'll be surprised by some of the things that are used. And this is an interesting one. Some of the tires in America, you use all weather tires in places where there's snow
Yes.
and things, right? And those tires that are used in rough terrains, years ago during the Apollo program, Goodyear actually sent those tires to the moon, right? And they didn't
Aha,
charge
okay.
us. Yeah, they didn't charge us for it, because they wanted to do it so they could say our tires have been on the moon, right? So they did that, and but to create tires for the moon, they had to figure out how, the roads there. There's no roads there, so then they had to figure
Right.
out how to make the tires more rugged. And so when they did that, now we use those tires here on Earth. I'll give you another example. There's this enzyme that we created a long time ago, again, for people that would be going on Mars. Um, but now that enzyme is used in all kinds of food here on Earth. Including not just baby food, but including potato chips. So the reach of the NASA spinoffs is kind of large, is kind of far. So I would encourage everybody on this call to actually look up NASA spinoffs so you can see, the depth of our in the impact that our research has. Vishal, you just froze. Okay, now you're back.
Absolutely. And the best part is it's not just the automotive industry there. It's the automotive industry, it's the cosmetic products, it's the health industry, every sector. That is what NASA is contributing. So IP is so evolving from NASA. So when we speak or think about NASA, the IP is not just about the space technology that NASA is working on. It is indeed, but it's contributing majorly. Specifically, every possible thing that we uses, some way or the other way, NASA might have contributed to the IP in that case.
Right.
And right. Why NASA? Okay, there is a comment from Suhail Ibn Sahanawaz. So he is writing why NASA failed to make Sunita Williams and the crew back and had to take assistance from Elon Musk to do that and had to wait so many months once the government changed, Elon Musk initiated, and again, NASA could not do it alone.
Yeah, so a couple of things. Let me clarify some things. So, years ago, we had, um, in the early 2000s, when we, or the, yeah, when we retired the shuttle program, right? We retired the shuttle because the shuttles had really outlived their design life, and it was becoming very costly to maintain them. So, and plus we wanted to go to Mars and the moon. So at that time we started a program is called Commercial Crew. So NASA decided that we would use the commercial industry, and we also wanted to spur the commercial industry. So we decided we would have the commercial industry take crew to space station. So at that time, we selected 3 companies competitively to develop this commercial crew capability. One of them was SpaceX. So the commercial crew, the capability that they developed, that they're now using, of course, it was done in partnership with NASA. And and then the second one is Boeing. And there's another one called Sierra Space, who's developing our capability to take commercial crude into low Earth orbit, into the ISS. So SpaceX, they delivered first a long time ago, in many years ago. So initially, what we do is we have them take up cargo. They have to be able to take up cargo, and then after they take up cargo for so many times, then they can take up people. So we have been using SpaceX. They're under contract to us to deliver cargo, or to deliver astronauts to the ISS and bring them back. And we have certain flights that are scheduled. Those flights for cargo and crew, they are scheduled. Um, so for Northrop Grumman, the one that Sunita Williams went on, that was the first, not Northrop Grumman, that was the first Boeing launch. And so we noticed some issues with that we were not understanding the physics of it. So once they got there, we decided not to bring them back on this spacecraft because until we understood the physics better. Because again, remember, people's safety is the highest priority. So it was not a rescue mission. It was a scheduled mission. There's 6 people who live on the ISS all the time. Don Pettit just came back yesterday. So people, but there's 6 people who are there all the time. So that mission, so we could have bought another mission right then. SpaceX is under contract to us. So we could have bought another mission from them, but we chose not to at that time, because that would have been, but instead we brought them back on the next mission, scheduled mission that was going to bring astronauts back. So that's kind of how the decision was made. So they were not stranded; they were working. The astronauts, they become astronauts so they can go to space. Like nobody, wants to say I'm an astronaut and I live on Earth. Yeah. So right. So the astronauts, they're a little different than we are. They want to be in space. So those astronauts, they did not mind the extra time they got in space. And Sunita Williams was actually became the commander, of the ISS while she was there, because of her experience level. So that's kind of how that evolved. It was not a rescue. It was not Elon Musk came and helped us out. It's a contract. We have a contract
Exactly.
with SpaceX. It's a long-term contract.
So, my dear friends in India, so Elon Musk has not been a rescuer in this case. There are few rumors has to be very much cleared right now. It was not a rescue mission by Elon Musk or SpaceX. It was a scheduled mission. Secondly, it is not the first program in which a private entity has collaborated with NASA for any kind of missions. NASA has been collaborating with lot many private entities time and again. Elon Musk, SpaceX is under contract anyway. So if NASA wanted to take any kind of an help, they could have taken it much before. It was a intentional decision to take a long time. It was because the NASA astronauts obviously had a long-term experience in staying in ISS. Secondly, if there was any kind of a mismanagement or diversification or diversion in the data, it could have resulted in their deaths or safety issues. So NASA did not want to uh, create any kind of a threats to the safety of its own astronauts. So it was more a scheduled mission, not a rescue mission, at least.
Right.
Right. Thank you so much, ma'am. And another question, it's about starting CIS universe in JNK. And in future, we are focusing to manufacture the aerospace stuff in the state. Any suggestions that we will be supportive to us? Okay, so Suhail is from CIS Universe. It's one of the first institutes that deals with space sciences in Jammu and Kashmir, state of India. So what he
Oh,
is saying is he has started CIS Universe, and he's quite a popular guy in quite recent times. He has been covered by a lot of news agencies. So he's asking that Like they are focusing on manufacturing stuffs in the aerospace sector in Jammu and Kashmir. So he wants some kind of a suggestions from you that can be supportive towards him. It can be in the form of funds that he can get, some kind of a collaborations that he can supposedly look for.
Yeah, so the space sector is really booming everywhere, including India. India is launching the NICER mission. Did you,
Yes.
right? And it's in collaboration with NASA. We're doing it together. And the NICER mission launch, I don't remember the launch date, but it's coming up soon. And so the space industry is booming in India as well. So I would recommend that you reach out to the space and to those industries there, to ISRO and the industry and the other industry partners in India to start for production there. Um, for NASA, I mean, I can put you in touch with some people. Well, we can talk. We can definitely talk.
Okay, so Hale, so once this session is over, you can directly contact me through our page or email ID. And then after I can move forward with Jaya Bajpayee ma'am for further details with your queries. Let's go to the scheduled questions that we have discussed. The question that now I want to ask is regarding the intelligent systems for space exploration. So
Okay.
every time that we are creating any kind of a intelligent system for space exploration is extremely complex and has to be. Now the point is, what are the biggest technical challenges that NASA faces in integrating AI and supercomputing in future NASA missions?
Yeah.
It
So
can be.
to start, we've got, NASA has used supercomputing and AI for many years. We invested in supercomputing back in the 1970s. That's when we started buying the supercomputers that are actually in my department here at NASA Ames. And we started investing in AI as early as the early 1980s. So this is not a new thing for us, and not every solution requires an AI. We use the AI for the solutions that require an AI. You have to use the right tools for the right to solve the right problems. You can't use the same tool for every problem. So for us, it's not much of a challenge. Integrating them is not challenging for us, just because we've done it for so long. We are a technical organization, as you know, and we're trying to do things that are impossible. So
Absolutely.
our engineers are very open. They always have been to using tools that are appropriate for whatever they're trying to do. Of course, we're not going to fly anything that's brand new, without making sure that it's well tested and that it will survive. The radiation environment, the space environment, and the launch. And also remember, if something breaks in space, we cannot go and repair it, right?
Exactly.
I mean, once you've launched it, that's it. So everything has to work perfectly. So so anyway, so for that, we've not had technical challenges. They're tools, and we use them where we need to.
Absolutely. And it is expected as well from the biggest space science company that we have in the world. Well, talking about quantum computing, quantum computing has been revolutionizing when we read about it in the trajectory planning for interplanetary travels using spacecraft. So, according to you, how might this technology reduce fuel consumption or reducing fuel consumption or shortening travel times compared to traditional methods before quantum computing?
Yeah, so let me talk a little bit about interplanetary trajectory planning. That
Yes,
is incredibly complex. That is so complex. And there for a number of reasons. One is, the distance between the planets is so large. Um, and then there are both the Earth and our destination planet, they're both moving. They're both, constant. I mean, we know the motion, so we can predict where there will be. And to get there, we have to know exactly it. We have to know exactly when to launch, to make the path most efficient, right? And then we have to make these precise maneuvers at precise times. So for example, for a 14-year mission, from we created this, we designed this mission. We were not selected to go to Enceladus, which is a moon of not Saturn, of another planet. And it would take us like 14 years to get there. And even to get to Enceladus, you'd have to make like precise maneuvers like 7 years from now at a certain time, and so that takes that's very, very complex. And of course, with these outer planetary missions, we like to fly by other planets that may be close by just to have a look, because how often do you go there, right? So that makes the interplanetary design very, very complex. And we want to get there as fast as possible and use as little fuel as possible. So those are the boundary conditions. So to look at it, so we have to look at a number of things. How hard the rocket throws us in the general direction of the planet, how much fuel we have, when we need to make these changes, etc. And there's so many scenarios that our mission planners look at. There's multiple scenarios, like almost a huge number of scenarios. So what to come up with optimum design. So this is where quantum is very helpful. Because with using quantum computing, we can look at all of these possibilities very quickly, and arrive at a fuel efficient, time efficient trajectory. So this is where we are, we're looking at using quantum.
Absolutely, and specifically when it's a long-term mission, when we're talking about Enceladus, that is the moon for Saturn, so it going to take a lot many years to, and secondly, for an example, we are not just saying or sending a spacecraft, we are also pre-deciding that on 4 years after being launched, what will be the conditions of outer space, where the planets will be, will there be chances of further collisions with an asteroid or a planet. So we have to take all these parameters into consideration, and it has to be extremely accurate, because there are $1 billion involved in each of the projects that we are talking about. And here, so quantum computing is going to be extremely important, as Jaya Bajpayee ma'am has told. And because it's not just about sending the missions, we have to be taking into consideration that lesser amount of money is involved. Secondly, we are reaching as soon as possible, and both needs to be go into a parallel direction. Specifically, I think money factor has to be very important once Donald Trump has gone to power.
Money is
Right?
always important. Money is always
Money is
important
always
for us.
important.
Money is always important because the cheaper you can do a mission, the more missions you can do. Right? I mean,
And that is the
because
most important part.
it's very important, right? Because if you use all of your money to do one little mission, then you haven't done much. So we watch the money consumption very closely. And we actually, if a mission goes over 15% of the budget that they said they would deliver in, we do have cancellation reviews, and we do cancel missions. So performing within the budget that one has promised is extremely important, and the time that they have promised is extremely important.
Well, in last time when India became one of the first countries to get a successful mission to Mars, and through Mangalyaan, of course. So almost all the media houses were rampantly talking about how frugal technologies is changing the space sector, specifically through ISRO. And ISRO is each time creating a new benchmark, including the Chandrayaan mission that ISRO sent, and we were able to get evidences of water in the darker side of the moon. So, how do you see the frugal technologies that are being talked about in regards to ISRO and India? And is it just because these mission concepts as well as the objectives are smaller? There's a reason that ISRO can do all these stuff at a lesser amount of cost, or is there some greater technologies into play? Because if the same has, because comparisons were made with the missions of NASA, with the European Space Agency, as well as the Hollywood movie. So it was even compared that US, the amount of money that US uses for a Hollywood movie like Gravity, ISRO can use the same amount of money or rather less than that to reach to outer space into the planets.
Yeah, so in any mission, and as in anywhere, the most of the money is spent in paying salaries. So that
Right.
makes a huge difference, right? The majority of the money is spent, is spent paying salaries, nearly all of it at some level,
Okay.
right? But
Yes.
there's very little, of like natural resources. I mean, if you think about it, there's the people that are planning it, that are putting it together, and then if you go down to the component level, say if you need a battery, there's people who are making those batteries, right? So they have to be paid. There's people that are making anything. So salary is a huge difference. That makes a big difference. Technologically, I don't know that technology saves you that much money. It gives you a lot of, especially new technologies, right? I mean, new technologies are usually more expensive. If you look at the cost of creating that technology from the ground up, those are usually more expensive. So less, using less technologically advanced things that you did not have to develop is cheaper. But I think salary is the biggest part. And then, of course, when it comes to accounting, there was a time when NASA, our missions were costs that we published were cheaper, but it was because we did not include the cost of the civil servants, the NASA employees, right? Because you have to pay them anyway, so they were paid out of some other account. So then when you looked at the cost of a mission, the civil servants' salaries were not included. But then when we went to something called full cost accounting. So for every mission, if anybody is spending any time on it, they charge to that mission. So there's so then and we did went that way because we wanted to know what the true cost of a mission was. And I'll give you an example. There's this big mission that we're planning. It's called Landsat Next. It's Landsat missions are actually owned by the USGS, US Geological Survey, but NASA has built those satellites for a long time. And so the next one is starting to be built. And I lead I lead the review team. I'll be leading the review team for that, the independent review team. So even now, the meetings I have, if I work on Landsat for 30 minutes, I charge my 30-minute time to Landsat. So that's kind of how, so that cost is going to go into the Landsat overall cost. So those are like some key differences, I think.
Well, there is a highlight into the response that you have given. It may not be the technical high-end things that we may be using, because anyway, when we are talking about high-end technologies, the research work that goes on has to be the investment that goes into the research work, the time that is goes on to research is going to make it more costlier. So when we're talking about the frugal techniques that ISRO uses, or sending the spacecraft at a lesser cost, maybe because we Indians are quite habituated in working at a uh, lesser salary from government of India, and that's the reason that we are good people, we are skilled people, but unfortunately,
Very
even when the
skilled.
government is paying us less, we will be sending our spacecraft any which way. Yes. And that's a good perspective actually, that needs to be understood. And we need to have government accountable for that, because we need our engineers to be paid more, because they are our real heroes, not the Hollywood or Bollywood actors and actresses. Like the people like Jaya Bajpayee ma'am are the real heroes. Coming to another question, that neuromorphic processors that mimic human brain functionality and adapt during the long-term missions. So, how could this technology improve spacecraft autonomy for exploring distant planets on missions? And can you highlight any of the missions that uses such kind of processors, neuromorphic processors that mimic human brain?
So neuromorphic processing is so interesting. It follows it's inspired. The design of neuromorphic processors is inspired by the human brain, right? And it focuses on how the brain processes information through, through interconnected neurons and synapses. And so neuromorphic computers actually use artificial neurons, artificial neural networks that kind of mimic the function of the of the brain. So what's important about it is that it's energy efficient. I mean, if you can imagine, if you can look at the difference between your laptop, the computer you have at home, and your brain, right? Your brain can process many more things, many more different kinds of things, new kinds of things, new kind of information that it hasn't seen before. It does not have, there's no cooling fan, right? There's no fans inside our brain. It does not heat up. So that's pretty cool. And your computer, which does a lot less, you have to keep it cool, and things warm up, and there's all kinds of issues like that. So neuromorphic computing, can be very energy efficient. It processes data very efficiently, and it's well suited for handling complex tasks autonomously. So, so neuromorphic processing, as we travel farther into space, the communication time increases between Earth and, and that planet. So you can't call Houston with all of your problems. Houston's not going to be able to solve them in time. As an example, the round trip communication time, and this has to do with the time of that the time of travel for light. So the round trip communication time between Earth and Mars can be as much as 40 minutes. So if you can, again, if you can think back to that movie, The Martian, and when that dust storm's happening, there's all of these emergencies, and if you can call back and you say, Houston, I have a problem, and then Houston, 40 minutes later, you hear back saying, what is your problem? And then you say that there's a dust storm, and then another 40 minutes goes by, they'll say, did you really mean a dust storm? I mean, you can see this is not, the way we communicate, this
Yes,
is not going to be helpful in times of emergency, especially as we go into deeper into space. So, and so for just faraway missions like Enceladus and other places, the communication time is even more because they're so far away. So this is
right,
not how, so things cannot be handled from the Earth. So we're really looking
right.
at something we call Earth independent operations. We're calling it that, and we're looking at a whole new area for how you can have Earth independent operations. Neuromorphic processors could improve a satellite's ability to analyze onboard data and take action because it can look at so many different kinds of information, process so many different types of scenarios, just as a human would. Um, yeah, so for missions to Mars, for human missions to Mars, we could use neuromorphic processors, to evaluate a lot of data and help in the decision making, help in a risk-based decision making. We at NASA, we like to think, we like to make decisions based on, taking into account the risks with each decision, or not taking that decisions. So we may have some decisions that are made by the processor. So those are kind of the things that we're looking at that neuromorphic processing may be useful in.
Absolutely, ma'am. And art independent techniques that we are talking about, it's extremely important because it will happen that the astronaut is in the need of an emergency, and the point is he has been injured or rather he has died, and now the Earth control center is talking about rescuing the person who is already died. So
Right.
such things must be avoided anyway.
Right.
And
Right.
right, and talking about digital twins, so the concept of digital twins is gaining traction in different engineering fields. So right now I am from the automotive sector, from the mechanical engineering domain, and I can see digital twin is getting used from either like both in the marketing segment of the automobile to the manufacturing segment of automobile, as well as in the battery technologies to identify which component will malfunction in due time using digital twin without even manufacturing it uh, from the industry. So how is NASA using digital twins to predict spacecraft performance and improve mission reliability during Artemis and Gateway programs?
Yeah, so the digital twin, although we did not call it a digital twin, if you look at the historical literature, the first digital twin, it actually came in. It was actually built at NASA in the 1960s, to model the Apollo missions. We call them simulators. Digital twin is a relatively new name. But we call them simulators. And we built an replica of the Apollo engines, the oxygen tanks, and then we used it to evaluate failures. Right. So we've been doing this we call them simulations. We've been doing this for a long time. So creating a model and a simulation of some real world physical component, a system, or some process, and even natural processes like climate or how or other things, it has long been an integral part of NASA's approach. So we create models to understand how systems, it's interplay between systems, for tolerances, to understand errors, and the error bars, and look at failure modes and what happens if this fails or that fails. It's much easier to do it. It's much cheaper to do it digitally than it is to actually build a system and then realize it would fail, and then you have to build a new system. That's expensive. So in general, digital twins give us a deeper understanding of the system. And then of course, from this model, we build engineering models, or and then as we test our engineering models, we'll go back and we'll refine the digital simulation, which these days we call digital twins. So this has been like a long practice, integral practice of how we've done it. And scientists follow the same process when they want to understand, some natural process. They'll build a simulation of that process, and then they, will go do some testing, not space-based immediately, all Earth-based initially, and then they will go back and they will refine their models based on what they're seeing. And then it kind of goes like that. Now, the advances in technology, it has really allowed us to build more sophisticated digital twins than we used to in the past. Now we call them digital twins. In the past, we used to call them modeling and simulations. And now they're much more sophisticated than they used to be, but they've been gaining in sophistication over the decades as technology has increased.
Absolutely. And this is the quite advancement that we are looking at, the simulation model and simulation techniques that we call digital twins, and that is making it more efficient and rather more accurate in predictive maintenance techniques. Now,
Right.
when we are talking, right, and now coming to supercomputing systems again. So, supercomputing has applications beyond space sciences. Now, how has NASA's expertise in computational modeling contributed to advancement in fields like aviation safety or renewable energy research? Although in previous responses of yours, we have discussed about how the IP of NASA has been contributing to a lot many industries, including the tires that we have discussed previously in the automotive sector. It is currently getting used. So can you give some examples of how supercomputing has an applications through NASA's expertise, and it is currently getting used in aviation safety, or most importantly in the sustainability sector?
Yeah, so if most people they associate space when they think of NASA, but if you remember, the first A in NASA does stand for aeronautics. So we do a lot of aeronautics, so we do a lot of aeronautics research and technology development to improve aviation, in this country and across the globe. So what are we using for supercomputing for aeronautics currently for research right now? We're trying to optimize designs of new aircraft for fuel efficiency, to reduce noise, to fly faster. We're also looking at airspace safety. Now that there's drones, there's more things flying in the airspace now than there has been before. So which means that the distances between aircraft is shrinking, and you have to shrink that safely. So we're looking at how can you design an airspace, and have and improve its safety. So airspace safety is a big thing. We're using supercomputers to refine aircraft design, to reduce drag, improve fuel efficiency, reduce emissions. Noise reduction is a big thing. We're using supercomputing to simulate and test noise reduction technologies, especially during takeoff and landing of aircraft. As aircraft go faster and faster, we want them to go fast but not make any noise, and use as little fuel as possible, and be very safe. So that's the end goal. We're also now looking at air taxis. There's a lot of talk here in Silicon Valley about air taxis. So you can, so should be able to call a taxi. They come here and they pick me up and they take me to work. So there's air taxis. So we're doing simulations using supercomputers to understand the aerodynamics of air taxis, the interaction with the ground stations, and the winds, and how to perform safe operations. So there's a lot of work going on in the aviation department, especially in the research field.
And the best part is NASA is not just leading in space sciences, leading in every possible industry, and contributing it as efficiently as possible for the newer technologies that we can look ahead. And thanks to people like you. And last question that we are almost reaching to the end time. So the last important question that we would like to ask, and that's for the Indian students actually. So for Indian students aspiring to work at NASA, what skills or areas of expertise should they focus on to contribute to advancement in intelligent systems or supercomputing, or rather, what exact skill sets are needed for getting into NASA, and what is the way forward to NASA? For supposedly, if someone is an engineering student, maybe in IITs and NITs, or a reputed central government university, or maybe a private university for that matter. So, what needs to be the approach?
Yeah. So as far as the technical skills are concerned, most of the universities, they are providing a good. The IIT, for example, provides great. They've got a great engineering program. The engineers that come out of there are awesome, right? And they're running a lot of the tech companies here, and that. So right,
Including Google.
including Google, right? So so I think from a technical standpoint, the engineers that come out of India and other universities in this country too, they have the technical know-how. Okay, now what we look for, so that's good. That's a good start. That's an extremely good start. And then, but the other things we look at is, is teamwork. Can you work with other people? Because if you notice, our projects are large, so one person can't do them all. So you have to work with a team. So the ability to work with a team in a team is very important. And your team are not just engineers. There's going to be scientists. There'll be accountants. There's going to be technical writers. There's administrative people. So all kinds of people will be there. There'll be graphic designers in the team, and communications people. So you have to be able to work with all of them and work well. In a conflict, you cannot be conflict averse, because conflict is good. It's, we like to embrace positive conflict, because that's where you have to, different ideas come up. And just because somebody doesn't agree with you doesn't mean they're bad or anything like that. You have to listen to them, and really, and really try to understand why they're saying what they're saying. And there may be a vigorous debate. We have instances when we might have a vigorous debate at work, and then and after work we might go out to dinner together. So people are not getting upset with each other, right? Because you're not debating on, it's important not to pass judgment, or to say judge things that pass judgment, but you're debating on a concept, and you can have a vigorous debate and then go be friends. Openness, willingness to contribute, this is very important. Sometimes, especially if we are told, if we think people don't want to hear from us, we shut down. So it's important not to do that. You should be contributing even when you think people don't want to hear, not in a respectful way, in a good way, but if people shut down, then we don't get those ideas. So it's important to be inclusive. And what we're saying is that, you really should look at NASA's values and, try to embrace them. Anybody can practice them, of safety, ensuring safety, integrity, doing things with integrity, teamwork, inclusion, which means listening to all opinions and all thoughts, and excellence, which is to do whatever you're doing, have excellence in your work. So those are the main things. And the space industry everywhere is booming. So NASA is a great place to work. The NASA contractors are also a good place to work, and we all work together. The space industry is extremely collaborative. We work with our partners across the globe. So the Indian space industry is also booming right now. I mean, that's also a good place to pursue.
Absolutely nice. And the point is, if you are in IITs, is a great place to start with. And then after you can have an experience in private space tech that is booming in India, including the Skyroot program that is in collaboration with ISRO right now. And get an experience here, and then meanwhile look for vacancies in NASA and then accordingly apply. Is that a right path to take?
So NASA is a federal government agency, so we look for people with U.S. citizenships.
Of course.
So that but that would be a way. Yeah, and again, remember, for any company where you work, the company has to have a job opening for a certain skill, and the person we're hiring has to have those skills and experiences. And when there's a match, then there's employment, and that's true everywhere, not just NASA.
Yes, and today we are actually in collaboration with BITS Pilani as well. So as you know, BITS Pilani is one of the most premier institutes in India, and it's in par with the IITs. And hopefully, few of the people from BITS Pilani who are listening to us today, some of us will be, I mean, aspiring to join NASA very, very soon and getting aspiring for our US citizenship as well. Although it has become a bit tough once Trump came into power, but any which way. And the last question that, again, that's a question that I, as a person, that would like to ask. So there are a lot many CSOs that are working in the skilling sector in India, including us. So we have impacted more than 1,35,000 people through a lot many activities. So NASA also has its STEM program for enriching the students in developing countries on space sciences, right? So
Yeah,
yes,
go ahead.
right. So there are programs in the NASA in order to enrich the students in developing countries on space sciences. So basically, if there are any CSOs, including us, who wants to reach out to NASA for any kind of a program that basically looks for NASA's core values to reach to the students, and secondly, the students in developing countries, maybe in the schools, maybe in the tier 3 colleges that we have in India, in remote places, remote towns, at least they get to know about these space sciences. So how big, according to you, is such kind of programs are being taken from NASA for, or are these programs can be taken in collaboration with CSOs, including in India?
It can. I mean, right, to inspire. So, a couple. You said a few things, so let me address as many as possible. So, NASA has a huge website, right? So, I would say to look at NASA's values and other things, you should look to the NASA website. We've got a gigantic website. So, you can look through there. You can also look at the website to see how you can collaborate with us in our outreach. We call that outreach. So in our outreach programs, and then yes, I would recommend doing that. Going through the website and reaching out. And of course, if you see somebody, if you see a program that you want to collaborate with, just write to them. You can
Absolutely.
absolutely write to them.
And that's the
Right.
best part that NASA does. It's not just about focusing its entire of technical focus on US alone, but it is looking for further development and enriching the students in developing countries too. This is what we were previously discussing with a previous session that we had with the STEM Research Center of NASA. Thank you so much, ma'am, for giving us such many insights. And we were not just discussing about the new techs. We were also discussing about, to an extent, geopolitics, as well as the way India and the Indian space tech is booming, and things that the way it is getting done in India. Thank you so much. It was extremely inspiring as well as insightful. One of the best sessions maybe we had. So out of the 400 plus sessions that we have taken so far. Thank you so
Wow.
much.
Thank you. Thank you for having me.
Yes, and your presence itself is so charming. So the way you speak so much, every fact that you speak, it shows the kind of, the depth as well as the enormous passion that you have on these space sciences. So it gets reflected in the way you present your topics.
Okay, thank you.
And
That's
that
good
is the most
feedback.
important thing to learn from you. So whichever job we are in, we have to be extremely passionate in our job, and it has to be reflected in our actions, in our words, in the way we feel for that particular subject. And thank you so much, ma'am. And hopefully this session was, hopefully it was, you felt good about the session as well. And thank you, everybody. Thank you, the collaborators, including Reliance Geo, Bits Pilani, Sys Universe, and everybody else. Thank you so much. Thank you, ma'am.
Thank
Hopefully,
you.
we will be joining again in future in some way or the other way, or maybe we will be in US to meet you sometime.
That'll be great. Awesome.
Yes, sure.
Thank you so
Thank
much.
you so much, ma'am. Thank
Okay,
you.
take care.